بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خير المرسلين سيدنا محمد صلى الله عليه وعلى آله وصحبه وسلم. I am pleasure to attend us in this conference. Now, in this lecture, we will be talking about optimal artificial limbs based on different biosensor signal. When talking about artificial limbs, we must different about this term because this term in English can't distinguish between artificial limbs and prosthetics. But in Arabic, الطرف الصناعي والطرف الاصطناعي confusing in this term because in Arabic الطرف الصناعي means traditional. It means prosthetics. And artificials must use الطرف الاصطناعي وليس الطرف الصناعي. Therefore, today we're talking about optimal artificial limbs based on biosensor. We're talking about the type of artificial limbs, human body signal, human body joints, properties of EMG and EEG signal, because these two signals will depend, the operation of the artificial depend on this type of signal, measurement of EMG and EEG signal, and example for this type of artificial limbs dependent on the position of the prosthetics in human body can get for a group of prosthetics. Below knee, above knee, knee joint. Below elbow, above elbow. In abbreviation, BK, AK, BE, AE. This two group can also divide by upper limb and our limb.
بالعكس.
Sorry. Type of according to the performance can also the prosthetics limbs. Now this category according to the performance. Dummy limbs and myo limbs. When got dummy, it means traditional. These limbs don't have sensor. But when you say myoelectric limbs or artificial limbs, that means these limbs contain sensors and controller and feedback from the real target with muscles or brain which control the limbs. According to the policy or technology for done the movement can get two categories from the limbs. Cable operating, that means cable for mechanical limbs. This two type mechanical limbs. That means the movement according to the cable, and when the apply the movement from the cable can controlled by the joint. Now this rest joint, this just handle gripper. And other type, prosthetics. That means artificial limbs. This must contain sensor, this EMG signal, electromyography signal, and controller, and this not just controller, a processing unit, contain filtering, amplification, and calibration. Control, just calibration between the amplitude of the signals of EMG according to the angle of the joints. In human body, we have 4 type signal, electrical signal. Electromyography signal, EMG, this generated from muscles, and we can detect in the skin, human skin, and EEG, electrosonography signal, that's from the brain and measured from the head. ECG, this is from the heart, and ERG or EOG, because this according to the movement of the eyes or the movement of the tongue in mouth. In artificial limbs, we use EEG and EMG. These properties or 2 features dependent in the artificial limbs, amplitude and bandwidth. We can see when compare EEG with EMG, the level of amplitude 100 microvolt, but the bandwidth 0.1 until 100 hertz, 10 until 1000 hertz. Therefore, these 2 signals described by stochastic random signal. When say stochastic random signal, that means this signal different from second to second, different from action or other action, different from body to another body. Therefore, the feature extraction for these 2 signals very complex. The human body contains 6 joints. In upper limb, we have shoulder joint. Shoulder joint has 2 movement, abduction and flexion and extension. Elbow joint have extension and flexion movement, and wrist joint has 2 movement. Also, in lower limbs has half joint, flexion and extension movement, and the knee joint, flexion and extension, and ankle joint also has 2 movement. According to the features from the EMG or EEG, can controlled by this movement of these joints. Now we'll explain the anatomy of EMG signal. EMG signal, after order generation in the brain, by electrical signal will send to muscles. Muscles contain from the liquid, and in chemical process will transfer the signals from motor unit to other motor units, and then this internal structures for the muscles, the number of motor units for each muscles, more than 1 million motor unit. This synthesis and this body itself and this action of the body. The electrical signal transfer from the synthesis according to the body cell. Inside the body cell has activation function, a threshold. After when this synthesis collected the signals until the threshold, then the transfer through the axon to other synthesis. The number of cells, neuron cells in body fixed from the brain until the diet, but the length of the axon different with life of a human. The features in for electromyography signal according to the extension of the load will get this shape. This shape, standard shape for electromyography signal. In artificial limbs, we use duration and amplitude. By amplitude, we calibrate it to get the degree of the joints. By duration, get the time for the capturing and relaxation. The sensors, before 28, we used needle. After 28, used surface. Now, needle just used for classification and detection for the muscles, disease muscles. But in artificial limbs, use just surface. This amplifies signal and after amplification and filtering will transfer to software for apply the process in electromyography signal.
Sorry, Doctor, do you mean resistive? This is a resistive?
This?
Yeah.
This amplifier.
Does it make a resistance?
No, amplification signal.
Okay.
And also filter, band reject filter, and notch filter. EEG signals, the category of EEG signal more complex for EMG signal because the features extraction from EMG according to the range of frequency. Beta and alpha and theta and delta. This form mean category for EEG signal. From 0.5 until 4 Hz, this deep sleep delta signal. That means this range of the frequency when the human apply relaxation or sleep. Theta from 4 until 8, this deep modification. Alpha from 8 until 13 Hz, eyes closed or eyes process. And 13 until 30, eyes open. The paper discussed with Dr. Ali, this group in our center applied this article when apply the abbreviation ERS. ERD means event related this synchronization. ERS, event related synchronization. That means synchronization with this range. Therefore, we must get the features when the signals in stage of ERS, not ERD. This practical project in EMG and EEG signal. In 2020, this first project, I explained in our center, this full synchronization used this sensor in same group detect signal from the skin and filtering the signal and amplification, and then apply two features, amplitude and duration, to apply interactive with robot. This for synchronize about the elbow joint and wrist joint. Therefore, this robot 6 degrees of freedom, but this joint and shoulder joint not move. Move just elbow joint and wrist. Look, this full synchronization. This is a huge process until get this result. This now used EMG signal to control by the movement of servo motor. This servo motor used to movement the joint. In other project, we'll use six servo motor to this one servo motor for the artificial limbs. This 6 servo motor to control the finger movement. Look, the full synchronization and full interactive according to this speed. Look about the speed in real limbs and in artificial limbs. Same speed, full synchronization in speed and in level of the joints. This same project, just EEG signal, more complex. This flowchart for the process for all the project. Brain, EEG signal, data, computer. Why use EMG signal? This big problem statement. Now, this real case in Ramadi city. This young, 17 years, explosion from the electrical transformer, therefore lost two upper limbs and two lower limbs. Just human from this and this. Inshallah, in next time we'll defend this case in our center to build upper limb and lower limb, inshallah, by using brain EEG signal. Therefore, we transfer working for artificial limbs from EMG signal to EEG signal. We used emotive brain computer interaction unit. And this two classification in the same two AI in same time. The first classification, this EMG or noise, because very sensitive about the noise. Therefore, first the classification about noise or EMG signal, and then features according to beta, alpha, gamma, and then brain computer interface, and then this to use emotive, because we must use wireless through the Bluetooth, because cannot use this same EMG. EMG can use by wire, but EEG must use Bluetooth to apply artificial limbs. After that, we can use Arduino, Raspberry, any microcontroller. And the first time to build my project step by step, first time working lid, different lid, according to color, blue lid, red, like that. Then servo motor, then different servo motor, then robot, then just hand robot, then 3D printer, artificial limbs. All this is step 7 project. Look, this is real.
At the beginning of the experiment,
Emotive
we trained the case study
can,
to control the cue
by
in the
imagination,
BCI
for
program
any
using some emotion,
human
moving it
can,
as required, and controlling it.
control
Satisfactory.
control the control the
At the
movement,
beginning of the experiment, we trained the case study to control the cue.
control the movement of this cubic, left, right, up, down, deep, and move. That means 3 degrees of freedom. After that, go to work according to emotion, eyes emotion, mouth emotion, and transfer this to control leg, servo motor, robot, and like that. Now, this for leg.
Yeah, we finalize for the initial session or go for the lunch break. If you feel like joining the
This,
sessions,
according to emotion, eyes or mouth,
thank you very much.
and then one control
Of course.
the servomotor.
Yeah, we moved horse to 301 in the education. 302, sorry.
Now,
Yes.
for servomotor, 3 servomotor, we use servomotor as DC motor on off or bus with modulation to apply circulation. On, the final, for capturing of the on. Thank you very much.
I'm sorry, I can't say I'm late. I have no late because the schedule changed from